Hi, welcome to N 9.2, demonstrating an understanding of rational numbers. Now, before we even get started, let me pick a color here. I'm going to underline a little word right here. Double underline. Ratio. So a rational number has something to do with ratios. Keep that in the back of your mind. Okay, in this outcome, you're going to compare these numbers, put them in order, see which one's biggest, smallest, relate it to other types of numbers. So we're talking about fractions and decimals and how they're all related, and then be able to solve questions. So first indicator says, put them in order. So if you're given numbers like 3/5, negative 0.66, 4.5, negative 5/8, be able to put those all in the same form, either all in a fraction form with a common denominator, which is kind of difficult. I would suggest doing it the other way and putting it all in decimal form. Once you have everybody in decimal form, then you can put them in order. The next next indicator, determine a rational number between. So if these were all on a number line, could you come up with a number in between? So again, you'd have to have them all in the same form so that you can compare them. Create a representation depicting how whole numbers, fractions, decimals, integers, square roots, and rational numbers are all related to each other. So these are all examples of rational numbers as well. Provide examples to explain how knowing how to add, subtract, multiply, and divide integers and positive rational numbers informs knowing how to add, subtract, multiply, and divide rational numbers. Provide examples to demonstrate how the order of operations, so we're going to be doing BIDMAS right there, and solve situational questions involving operations on rational numbers with or without calculators. Analyze a simplification of an expression, so maybe not an actual equation, just an expression involving rational numbers. Okay, here we go. All right, there's that word again, ratio. So it can be written as a fraction. So 8 can be written as 8/1. Okay. Even a big clunky number like this is rational, since it can be written as a fraction. So any fraction is a rational number. Every whole number is a rational number. Anything that's irrational, here's a good example down here, pi. It's endless. There's no repeating digits. It just keeps going on and on and on and on and on. That's an irrational number. Okay, so here we go with some calculations. We have to put these on a number line. And starting with 3/5, you could easily type this into a calculator. Let me get one there. Okay, so if you type this into a calculator, you would get 0.6. This one is already in decimal form, 0.666, 0.04, 0.5, and again, type that into a calculator, 1 divided by 8, because the fraction bar means divide. Okay, remember that, 1 divided by 8, and you'll get 0.125. Now they are all in a form that we can compare. They are all match. So you can't compare fractions and decimals unless you have them all in the same form. So now we can look at our numbers and say, well, the smallest one appears to be this guy, because there are no tenths, there are only 4 hundredths. And so if this is a number line, this is 0 all the way to 1. Okay? And there are 100 little marks. There's the fourth one. Okay, there's 0.04. The next one, we have 6, we have slightly bigger, 5, and we have a 1. So 0.125 would be next. So here's 0.1. Right here would be 0.15. This is 0.11. And so 0.125 would be right about there. Nice printing, I know. Okay, so we're done that one. After that comes 0.5, and that's easy to locate. It's right there. And then 0.6 is next. Okay, so this is 0.61, 0.62, 0.63, 0.64, 65, and 66. And so 0.666 would be right in there somewhere. Okay. So notice on this number line that when you have a whole unit, this is from 0 to 1, that can be chopped up into tenths. So here's an example of a tenth from 0.3 to 0.4. And each of those tenths can be chopped up into hundredths, because you can chop that into 10 pieces. Okay? You could take one of these hundredths and magnify it and chop it into 10 pieces as well, giving you thousandths. So everything can be split up and split up and split up, and that is the whole spiel with decimals. All right, back to rational numbers. Radicals that are square roots of perfect squares, cube roots of perfect squares, they can have a decimal representation that terminates or repeats. So the square root of 16 is 4, so this is a rational number. The cube root of negative 27 is negative 3, so that is a rational number. The square root of 64 over the square root of 81, just like that, 8/9. And anything that can be written as a fraction is a rational number. So square root of 36, and the square root of 25 over 100 ends up being 5/10. So all of these are rational numbers. Rational numbers can be positive or negative. So integers, and integers, think of your number line again. So anything that's negative, like -9 or -72. Fractions, like 1/2. Mixed numbers, like 2.5. Percents. Terminating decimals. Repeating decimals. Okay, those are all rational numbers. So here are some rules. If you're going to add, you need to have, let's see, here we go. Same sign. So if they're both positive, you add and keep the sign. So 2 positives make a positive. Different signs, you're going to subtract. Use the sign of the bigger number, then you'll be exact. This just means that if you're adding a negative number and a positive number, that you're basically doing 7 take away 11. Okay. If you're adding decimals, you need to line them up. So 0.07 and 0.4, make sure these decimals are lined right up. And then in your answer as well. If you're using fractions, you need to find a common denominator. So you can't add a half and a third. You cannot, until you've converted them both to something with a common denominator. There you go. If it's a mixed number, you can't really do anything with a mixed number because it's really difficult to work with a mixed number in an equation. So if you have 2.5 plus 3/4, you need to change the 2.5 into an improper fraction first. So 2 times 2 is 4, plus 1 is 5 halves. We still can't do anything with it because the bottoms don't match, so we have to change 5 halves. Okay, and then remember as well with rational numbers such as fractions, you need to find lowest terms. So 4 goes into 13 3 whole times, 1 left over. Further rules. Now this slide, I stole it from the internet. I don't know what this is, probably some fantastic strategy that some teacher used. I don't know what that is, so we're just avoiding that one. So if you're going to multiply rational numbers, well, if it's decimals, you would multiply like normal and then count the number of decimal places in the problem, and that's how many you have in your answer. So if you're doing 0.7 times 0.1, well, 1 times 7 is 7, but you have 1 decimal place here and 1 decimal place here, so that means you would go 2. If you're doing fractions, multiply straight across and reduce if possible. So if you have something like 4 over 5 times 10 over 11, you could multiply straight across. You can also reduce first. You can say, well, 5 and 10 have a relationship. It goes in once, and a 5 goes in there twice. Now I'm going to multiply straight across. 4 times 2, 1 times 11, done. Okay, again with mixed numbers, you have to change to an improper fraction first and then go back and follow your fraction rule. Dividing, I've got to find out what this tic-tac-toe board is. All right, if you're using decimals, the outside number has to be a whole number. What you do outside of the box, you must do inside of the box. Move your new decimal straight up and divide like normal. So if you're using a Dave, they've called it a box. I think our name is just slightly more creative, that's right. Okay, if you're using a Dave, the outside number has to be a whole number. So if you have something like 3.1 and you're dividing that into 8, Dave doesn't mind having a decimal inside of the Dave, but he hates having a decimal out here. I'm just going to change colors. He does not like that. So multiply this by 10 and move your decimal over. So now you have a 31. What you do to the inside or to the outside, you must do to the outside. So you're going to multiply that by 10. Now your decimal's here. So 31 into 80 would give you the same answer as figuring out 3.1 into 8. If you're using fractions, you keep the first number. If you're going to divide a fraction like 1/2 divided by 3/4, it says keep. So you're going to keep this number the same, change the sign. We are now going to multiply, and flip. We always flip that second fraction. So that would be 4/3. So 1/2 times 4/3, and then you multiply straight across. 1 times 4 is 4, 2 times 3, 6, and you can reduce that. There, 2/3. And again with mixed numbers, you gotta have an improper fraction first. And then all right, good luck with rational numbers.